I'm going to do 2 lessons on 1.10. So this is going to be 1.10a, and the objective is I can classify and compare real numbers. And the first thing I need you to do is I need you to copy down this diagram, and the whole diagram is about real numbers. Oops, I misspelled numbers. And there are numbers that are not called real numbers. Real numbers is a category of numbers. Numbers that are not real are called imaginary. That doesn't mean they're fake or they don't exist. That's just the category they're in, and that's square root of negative numbers. We're not going to deal with that anymore this year. But underneath real numbers, you need to have a rectangle. And within your rectangle, you're going to cut it not in half, but maybe like into 2/3 and 1/3, like this. And over here, you're going to put rational numbers. And here is going to be irrational. Rational and irrational are our two most important categories for this year. And I'm going to put the definition of a rational number down here. A rational number is any number that can be written as a fraction. You can tell if it's a rational number if it's a decimal that ends, decimal that terminates. Terminates is another word for ends, or repeats. We know how to put terminating and repeating decimals as fractions. So decimals that terminate and repeat are rational numbers. Within the rational numbers, we're going to go back up to our diagram. Within the rational numbers, there are a couple of other categories. I'm going to draw an oval kind of like this. And then this oval is going to be labeled integers. Integers are whole numbers and the negatives and 0. We're not going to write that definition down though. We should have done that last year. And then within the integers, we have the whole numbers. And the whole numbers include 0, but they don't include negatives technically. And then within the whole numbers, we have another category called the natural numbers. And the natural numbers, that's unreadable. Do that a little better. The natural numbers just don't include 0. So the natural numbers are our counting numbers like 1, 2, 3, 4, 5, 6, all the way up. They have to be whole, but they cannot be 0 and they cannot be negative. So we're going to take a number and we're going to classify it into the smallest category that we can. Look at our diagram. Integers fits inside rational. Whole numbers fits inside integers. So some of them will fit in multiple categories. Okay, if our number is 1/2, is 1/2 rational or irrational? Well, we know it's rational because it can be written as a fraction. It already is a fraction. Let's think, does it fit inside integers? Nope. So it's going to go out here because that's the smallest category it fits in. What about 0.4 repeating? 0.4 repeating is 4/9, so that can be written as a fraction, so it's rational. Is it an integer though? Nope, because it can't be written without a fractional component. So 0.4 repeating is going to stay outside in the rational category. Okay, what about pi? Pi is a decimal that never repeats and never ends, so if it doesn't fit in that category, it's going to be irrational. Pi is an irrational number. What about -8? -8 can be written as a fraction, -8/1, so I know it's rational. Is it an integer? Yes, it can be written without a fraction, so it goes over in here. Is it a whole number? No, whole numbers does not include negatives, so it's going to stay out here. What about 3? 3 can be written as a fraction, so it's rational. Is it an integer? Yes, it can be written without a fraction. Is it also a whole number? Yes, it's positive. But it's also a natural number, so it goes inside here. The only number that would be in this whole numbers category would be 0. That's the only number that can't fit as a whole number and a natural number. What about the square root of 5? The square root of 5 is a decimal that never ends and never repeats, so that's going to be an irrational number. What about 0.45? 0.45 is a decimal that terminates, so it can be written as a fraction, so it's rational. Is it an integer? No, so it's going to stay out here. The main definition that you need to know for this year is a rational number and be able to classify numbers as rational or irrational. So rational means it can be written as a fraction. We have all these subcategories inside. Irrational means it cannot be written as a fraction. The only other thing we're going to talk about in today's lesson is comparing real numbers. So these kinds of problems will say, fill in the circle with less than, greater than, or equals to make the statement true. So you might have something like the square root of 10, circle 3 1/3. And the easiest way to compare real numbers, I think, is to turn them all into decimals. So the square root of 10 as a decimal, I'll type that into my calculator, is 3.162278, and it keeps going. 3 1/3 as a decimal, I know how to turn fractions into decimals. It's going to be 3.3 repeating. They have the same value in the ones place, but if I look in the tenths place, this one's greater, so I'm going to put the alligator eating the 3 1/3 because this one is greater. Let's do another example of that. Let's do the opposite of the square root of 7 and -2 1/4. So I'll type in the opposite of the square root of 7 in my calculator, and I get negative, should put a circle in between, I get -2.65 if I round. -2 1/4 is -2.25. I have to be careful because these are negative. This one will be further to the left, this one will be further to the right, so I'm going to still say this one is greater. Okay, the last one we're going to do is, let's compare the cube root of 30 and 2.9 repeating. So I'll type in the cube root of 30 into my calculator, and I get 3.107, keeps going, but I rounded. 2.9 repeating I know is less than 3. This one's greater than 3, so I'm going to put in a greater than sign like that. The alligator's eating this one because it's greater.